Let P be a prime, then so that factorial P minus 1 plus 1 congruent to 0 modulo P. PYQ of 2020 IFOS. It's a part of algebra, modern algebra. So we have to show that let P be a prime, then show that factorial P minus 1 plus 1 congruent to 0 modulo P, or same can be written as or factorial P minus 1 congruent to minus 1 modulo P. This is known as also Wilson's theorem. इसे हम विल्सन थ्योरम भी बोलते हैं. What we have to do actually, if P be any prime number, that means if P be a prime, then we have to show that factorial P minus 1 congruent to minus 1 modulo P, and we know that the what is the mean of A congruent to B modulo M. A congruent to B modulo M, that means M divides A minus B. So we have to prove that. So we'll see that how to prove that. Proof. Consider the group of prime residue classes modulo M. Consider the group of prime residue classes modulo P, that is UP with the multiplication. It's a group of prime residue classes modulo P. It's a group with respect to multiplication in residue classes. And what is the set here? Here, how to define this set? A class means A bar belongs to ZP such that A and P are co-prime. GCD of A and P, this is a symbol of that means AP, that means GCD of AP equal to 1, means A and P are co-prime. Then this is said, this set forms a group with respect to multiplication in residue classes. So now consider this set, consider the group this. So now first we will see, okay, it's a group with respect to the multiplication in residue classes. And first we have to find which, if it's a group, then satisfy all the conditions, that means closure law, associativity, identity, and every element has inverse. So we have to first find which element are inverse to itself in a group. In this group, which element are inverse to itself. So let A bar belongs to UP such that square equal to 1 bar. That means element which is inverse to itself, that means A bar square equal to 1. Identity element, this is the identity element of the group, or this can be written as imply that A square congruent to 1 modulo P. And now that imply that A congruent to B modulo P, that means what? A congruent to B modulo P, that means M divides A minus P. So here we are getting A square congruent to 1 modulo P, that means imply that P divides A square minus 1, and that imply that since P is a prime, and whenever the P divides A1 dot A2 dot so on an, then P divides either A1 or P divides A2 and so on. So here P divides A square minus, that means 1, imply that P divides A minus 1 or P divides A plus 1. P divides, simply P is a prime number and divide here A minus A into A plus 1. That means P divides A minus B or P divides A plus 1. So now just observe this equation. So what is the element here? in this case, what are the element actually? 1, 2, as p is a prime, number, so obviously here we'll get the what? Up to p minus 1. Up to p minus 1 element. So which element will satisfy this condition? If you put a equal to 1, that means 0, then p divides 0. And from this we can get the, if we put the array equal to p minus 1, then p minus 1 plus 1, that means p divides p. So only 1 and p minus 1 are satisfied this. That means only two elements, 1 and p minus 1, are the elements of this group which are inverse to itself. We have solved this equation, that means this relation, and we are getting actually either 1 or p minus 1 satisfy this condition. That means what? That means only 1 and p minus 1 are the elements of this group which are inverse to itself. So now it is clear that only 1 and p minus 1 bar of this group which are inverse to itself. That means 1 bar equal to 1 and p minus 1 square equal to also 1 bar. Only two elements. And now what are the rest element? What about the rest element? That means 2 bar to p minus 2, and these are in numbers how? So here we have total p minus 1 element. So just reduce two elements, then we will have the p minus 3 elements more. And since this is a group, so obviously every element has the inverse element. So remain element, that means up to 2 bar to the p minus 2, will be in pair to their inverse elements, as this is a group, and if this is a group, then every element has the inverse. And now as 1 and p minus 1 are inverse to itself, then obviously rest element, that means 2 bar to p minus 1 bar, will be in pair with their inverse element. So therefore remain elements, that is 2, 3, p minus 2, are in pair of their inverse elements. That means pair. So now therefore take the multiplication. Therefore take the multiplication of all those elements, all the elements, we get 1 bar, 2 bar to p minus 2 bar to p minus 1 bar equal to what? So obviously from 2 to 2 minus p minus 2, these are elements in pair. Like suppose the 2 is, just for example, suppose 2 is the inverse element of 7, just for example. That means, so obviously, and this is a abelian group. U P with respect to multiplication is an abelian group. So order doesn't matter, we can take any element with anyone. So like for example, if I'm saying that the 2 is the inverse element of 7, that means we can take the 2 and 7 together, and multiplication of 2 and 7 will get the 1. So similarly, all the elements from 2 to p minus 2 are in pair, and they will be cancelled to each other. That means multiplication of all these elements will get the 1. And now 1 and p minus 1 will be remain. So this will become the 1, and we will have the what? 1 into p minus 1. That means p minus 1 this. Or now taking together from left side, so we'll get the 1, 2, 3, p minus 1 equal to, what is the p minus 1 bar? Modulo p, that means minus 1 bar. And now this is the factorial, that means imply that factorial p minus 1 bar congruent to, that is now just, so if we use the bar, then we write the, okay, equal to minus 1 or factorial p minus 1 congruent to minus 1 modulo p, or factorial p minus 1 plus 1 modulo p. So this is the proof of Wilson theorem. So here given that means you have to show that what, if p be a prime for any prime, factorial p minus 1 plus 1 congruent to 0 modulo p. So we can prove by using group, just consider the group of prime residue classes modulo p with respect to multiplication. So here what are the elements in this set? So 1 to p minus 1 bar. Then first find which elements of this group are inverse to itself. So general take any arbitrary element and solve by using the inverse, that means inverse to itself, that means what, a square equal to 1 identity element. That's all. We will get the only 1 bar and p minus 1 are two elements which are inverse to itself. That means rest element are obviously in will be in pair with their inverse elements, as U is a group. That is, UP is a what, group with respect to multiplication. So obviously every element has the inverse. So now directly take the multiplication of all the elements. Take the multiplication. Now this is the factorial p minus 1 bar, and now p minus 1 equal to what, divided by p modulo p, that means divided by p minus 1, or you can write the factorial p minus 1 bar equal to minus 1 bar, or factorial p minus congruent to minus 1 modulo p, or you can also write the factorial p minus 1 plus 1 equal congruent to 0 modulo p. So for any prime this condition holds. For example, if p equal to 7, then p minus 1 factorial congruent to minus 1 modulo 7, as 7 is a prime, obviously 7 minus 1, that means factorial 6 plus 1 congruent to 0 modulo 7. That means 7 means what? 7 will divide the factorial 6 plus 1. So this question has been asked in the IFOS 2020, then 2020. We have to prove that this theorem, and also they have asked the one application to find the remainder by using the Wilson theorem, and also use the format theorem. So we will see the proof of the format and Euler's theorem in the next videos. So we will stop and we'll see the next PYQ of algebra in the upcoming videos. Thank you.